right, everyone, Ms. Folk here again, and now we are on 13.1, which is on page 899 in your book, okay? So for our first definition here, we have our sample space. I already went ahead and wrote out the definition, but I'm missing the part that a sample space is represented by and we can represent it by three separate things: a list, there we go, a list, table, or tree diagram. You do need to know how to do all three of these, but sometimes you will just be asked to write a sample space so you can pick which of these three methods you prefer. So reading this, we have an orange and red marble in a bag. Our marble is drawn, the color is recorded, it's returned, and then we repeat the process once more. So for representing a list, we could say we grabbed a red first, put it back, and we grabbed the red again for our second turn. So I'm going to say first and second here. So that's one item in our list. Then we could also pick a red first and an orange second. We could pick an orange first, an orange second, and we could pick an orange first and a red second. So here we have 4 outcomes. Okay. Now, if you list them out like this, that's fine. If you list them horizontally, just make sure you have those commas in between your outcomes, okay? Now, for a table, here is how we set up a table. We're going to always have an outcomes column. And in this case, we have 2 possibilities for each pick, okay? So here's what our table would look like. Again, we could pick a red first or an orange first. So I'm going to say my left side here is representing a red first or an orange first. And then my top row here, I could say I could pick a red second or an orange second. Okay? So those are my actual outcomes. So for my possible answers here, it's kind of like looking at a multiplication table. So here and here, where do those cross? We would get a red and a red. Hopefully that's making a little sense, drawing it, color coding. Now we could also see if I picked a red first and an orange second, where do they overlap? Right here, and that would result in red-orange. And again, here we could have our orange first, our red second, where do they overlap? Right here. And our last one, we would have our OO. Okay? And again, we see that we do in fact have our 4 outcomes. Now, finally, for our tree diagram, again, we're going to start with our outcomes listed at the very top here. Now, we have 2 options. We could pick a red or an orange. So this is my first pick. Now, once I did that, I technically have a second pick. Okay? And for my second pick, pretend I picked my red first. My second pick, I still have a choice of a red or an orange. Same idea, if I had picked an orange first, I still have a red or an orange available for my second pick, okay? So for my actual outcomes here, now all I have to do is list at the very bottom of that tree. So hopefully you'll be able to follow along with my highlighting here. Follow down your tree. Let me do a different color here. Okay. So this could represent getting a red and then a red. Now let me put this in red here. Or I could have gotten a red first and then an orange. Okay. Now here to the right, if I got an orange first and then a red. And I could have also done a orange and then an orange. Okay, and again, I did get my 4 outcomes. So just in case you're afraid, like the only thing I say, I prefer doing a table or a tree diagram because with a list, it's kind of easy to forget one if you have multiple different options. For this specific example, since we only were dealing with 2 colors, it was pretty easy, okay? But sometimes it can get a little bit complicated. All right, so moving down here, we have the fundamental counting principle. And this is on, let me look here, page 901 in your book, okay? So basically all it is a way to solve for the total number of possible outcomes. So there's a bunch of symbols and notation for this, and they're written as n sub 1, n sub 2, n sub k, and n sub k is just representing, you could have k be equal to 1 million. You're just saying you could go all the way up to a million, billion, trillion, whatever you want. So looking up here at our tree diagram, technically, oops, I'm sorry, I'll do this in blue here. Technically, this first pick that I'm putting a box around, that's stage 1. So my N1 for my example up there was 2. I had 2 options, okay? Now, my N2, my stage 2, my second pick, I had 2 options again for each pick. So notice I have 2, let's see, branches coming out of each thing. Do we all see that? 2 branches. So my total number of possible outcomes, I would do 2 times 2, and I do get 4. So I know I made my tree diagram, table, and list right because I just checked it with the fundamental counting principle. And again, this is a lot more detailed in my key and in the book, but I just wanted to go over it so hopefully you can get a little bit better of an understanding. All right, for this note here, we have sometimes listing the entire sample space may not be practical, okay? So for instance, we could have a bag that has every single number known to man up through infinity. It's not going to be probable for us to list every single possible outcome up through infinity, okay? All right, looking at our first example here, okay? We have chicken tenders at a restaurant come with 3 sauce options, our barbecue, honey mustard, or plain. And they come with 3 side options as well. So let's go ahead and make a list first. We could do a barbecue first with a fry. We could do a barbecue and a salad, a barbecue and no side, okay? That's all my options where barbecue is first, okay? And then we could do, let's see, we would have honey mustard and our fries, honey mustard, our salad, honey mustard, no side, and so on. So I'm going to go ahead and actually pause the video here and suggest that you try to finish out that list, finish the table, finish the tree diagram. The only thing I didn't mention up above for the tree diagram, I had this one going vertically, up and down. You are more than welcome to do a tree diagram sideways, which I would recommend for the space I gave you here. So I'll at least start it out for us. So our outcomes, let's say we could have gotten barbecue first, honey mustard, and plain. Now you guys have to figure out what's going to come off of all those, okay? All right, so again, take the time and pause the video here. All right, hopefully you took the time to pause the video, but here are our answers. And again, I do have these also on the key, but one important thing I want to note, I could have technically had, looking at my table here, I could have had the barbecue, honey mustard, and plain up here, and I could have had the fries, salad, and no side down here. It doesn't matter, okay? So if your order of these were different, that's totally fine as long as you still have all the outcomes accounted for. Same idea with the tree diagram. Oops. Here, instead of starting with barbecue, honey mustard, and plain, we could have technically started with fries, salad, and no side, and then had our sauces come out of those, okay? But either way, you should have gotten 9 outcomes for every single time, okay? And that's all for that question. Okay, for number 2 then, we have using the table below, someone is ordering 1 of each item, and we have to find the number of possible outcomes using that fundamental counting principle. Again, that's right up here, okay? Also, I guess I didn't write this out, but your fundamental counting principle in general, you're always doing your N1 times your N2 times ... all the way up through your NK. I'm sorry, I thought I wrote that down earlier, okay? So knowing that now for number 2, if we're ordering 1 of each item, this is technically our N1. This could be our N2, our N3, our N4, and we go up to N5. So our total possible outcomes is just going to be all those numbers multiplied together, okay? So I guess I could write them over here. So we would have 6 times 7 times 4 times 10 times 3 which does result in 5,040. So this is our number of possible outcomes, okay? So that's all that formula is telling us. We're just multiplying all of those out, okay? Now I'm going to stop the video here. I want you guys to do these next few questions on your own and then check your answers with the key. But as always, please feel free to shoot me a text via Remind or something. And I will see you hopefully for our Kahoot tomorrow at the Zoom meeting.